So, good morning all of you. In this video I am going to discuss a force between the parallel currents. Okay. So, here I am going to calculate the magnitude of the force between the two current wires. Okay. So, let us take a wire, consider a wire W1 which carries a current I1, and take a current the wire W2 and current which is carries is I2. Okay, so I am going to place these two these wires at a distance d. These two wires are apart from a distance d, and these two wires are parallel, and the direction of current is also in the same. Okay, so definitely this current wire will produce a magnetic field. So now I am going to calculate what is the force due to this field on this current wire Y2 or W2. And also what is the force on this W1 due to this current carrying wire I2. Okay, so here the force I am discussing is magnetic force, because this moving current will produce a magnetic field, and this current is also produce a magnetic field. Okay, so let us take a small element dl here. So first I am going to calculate the magnetic field here. Okay, here in this place. So we know that by Biot-Savart's law, the magnetic field for a moving current wire is B is equal to mu naught I divided by 2 pi distance where you are calculating the magnetic field. So here my distance is d. So this is the magnetic field in this region due to this current I1. So your current is I1. Okay, so this is the magnetic field here in this region. Next, okay, and the direction of the magnetic field here due to this current is into the board, which is perpendicular. Okay, so here in this directions. And so now I am going to calculate the force. So here there will be a magnetic field. Definitely this magnetic field will exist a force on this current wire, right? So the force df on this small element dl from this current is dl is equal to current I2 into dl cross b. So this current I2 is the I2 current here. It is on this, because we are calculating the current, the force here, right, on this chart and this wire. So I am going to take this current, the magnitude of the current I2, because the magnetic force is also depends on the magnitude of the current. Okay, so where you are calculating that, and dl length element cross b, but here this dl cross b is perpendicular. So I am going to write this as I2 dl, and this b is mu naught I1 divided by 2 pi d. Okay, which is equal to I1 I2 mu naught divided by 2 pi d into dl. So this is the force in this region only. Next, the force per unit length, the force per unit length of the wire is, so df divided by dl. So per unit length of the wire, df by dl is equal to mu naught I1 I2 divided by 2 pi d. I am going to replace this force per unit length, F is equal to mu naught I1 I2 divided by 2 pi d. So this is the magnetic force per unit length of the wire. So due to this current carrying wire I1. Okay, and the direction of the force will be in this direction. If suppose see this is our moving current if forefinger represents the moving current, direction of the current, and our this middle finger represents the direction of the field, magnetic field, and the thumbs gives the magnetic force, direction of the force. Okay, see, this is the force per unit length of a wire, and so here we calculated the force on this current I2 due to this current I1. So what is the force on this current I1 due to this current I2? So what is the force on this on this current I1 due to this current I2? Means force means magnetic force. So then only it will give same answer. Okay, because these two are parallel currents and the magnitude of the current I1 and I2 are same. Okay, and they are separated by a distance d. So the magnetic force on this current I1 is also same due to this I2, and which gives the same answer, F is equal to mu naught I1 I2 divided by 2 pi d. Okay, if these two wires are anti-parallel to each other, so then they will be repel each other, then the force will be repel. This wire does not goes near and they will not attract, so they try to repel each other. Okay, see, so for this current I1, the magnetic field is like this. Here it goes into the board, here it come out from the board. Okay, so it will like this only, and this this current also produces a magnetic field, but the magnetic field here in the wire due to this current I2 is 0. They are parallel and the angle between them is 0, so it will not affect the magnetic field produced by the same current. And here also which gives, see, the magnetic field produced by this current is like this. Okay, so obviously these are in different poles, different directions, so definitely they will attract each other. Okay, so definitely they will be, the force is attractive. This is the magnitude of the force on this current I2 due to the magnetic force, due to the magnetic field and force from this current I1. Okay.